Alright, I think this is recording. I'm not really sure which ones you still need help on, so we are going to just try to hit them all really quick. I'm just going to start with, I don't know, what I think to be maybe one of the simpler ones. This is going to be right here, Pythagoras. What you're going to do is you're going to take that triangle. They want to know that distance of x. Sorry, my drawing is hideous. But you got the right triangle here. You got a 3, 5, and they want this whole thing x, but there's a theorem that you probably had. If you have a radius hitting a chord perpendicular, it's going to cut it exactly in half. So we're just going to call this something like y, and then when we get the answer, we'll double it. And of course, y squared plus 3 squared equals 5 squared. And so you have y squared plus 9 equals 25. And then, let's see here. Sorry about that. Subtract 9 from both sides, so y squared equals 16. So y would equal plus or minus 4. Of course, we take the plus 4 and double it, and x would equal 8. So that's 44, basically how to do that one. All right. Next, I like this one. There's a generic circle formula where it's x minus. It's kind of important that the minus is there instead of a plus. And then you have y minus k squared equals radius squared, where if it's set up like this, the center, I might have some dead batteries here. Center is the point HK, the radius equals R. Like x minus 3 squared, y plus 5 squared equals 9. Your center point would be 3, negative 5, and the radius would actually equal 3, because this has got to be the radius squared. So as we look up at your problem, it looks like the center point is 2, 1. And it looks like it has a radius of 2. So when we go to do this, I wonder if I have other colors I could use. When we go to do this, it would be x minus 2. Again, it's like the opposite sign of whatever you're doing. X minus the x value of the center point, plus y minus 1 equals 4, radius squared. And that's that problem. So I will try to erase all of that stuff. Next problem, there's a thing if you have a circle and two chords intersecting. Again, it's another theorem. I'm kind of disappointed that those are both 5s, because that can be confusing. But let's call this little segment A, this little segment B. A and B make up one chord. And then this little segment we'll call X, and this little segment we'll call Y. And the theorem is that A times B equals X times Y. So for your example, X times 5 equals 5 times 11, or 11 times 5. Again, that was kind of a silly example to use 2 5s there, because that just makes your answer 11. Because you divide both sides by 5 and x equals 11. So that's that one. The next one, if you have a inscribed angle, then the arc that it cuts out will be double. or the inscribed angle will be half of the arc. So in this one, x equals 90. That's another theorem that you probably have. This one is if you have a chord or a secant. It could be written either way in your theorems. That's this one coming through here. Intersecting a tangent at the point of tangency. So imagine this going even further. Again, it's kind of like if we were to take this side of this and keep extending it out till it was a tangent, it's still going to have the exact same formula. So the measure of the angle will be 1/2 the arc. So since this is 150 degrees, half of 150, your angle on this one, number 43, is going to be 75 degrees. All right, so here, a little practice with your circles. This is a circle with a radius 3. That's the same thing as y minus 0. So x plus 2, you'll have the center point at 2, comma 0. So there's your, oh, I got to make my little pen thing go again. You got a center point at 2, 0, with a radius of 3. So I like to do this. This is going to be maybe the worst circle ever drawn in the history of man. So you got a circle, or an amoeba, and then you have y equals negative x plus 1. See, that'd be here. So you're going to have something coming up about like that. They want to know what are these 2 points that intersect. Again, my drawing is hideous. So bottom line is you can do a couple different methods. I would substitution method here. I see that I have y equals negative x plus 1, so that can go into the other equation for the y. So you'll have x plus 2 squared, lost my place, plus y squared equals 9. Again, I'm rewriting this equation right here. Now I'm going to put negative x plus 1 in because they're equal. So we got x squared plus 2x plus 2x. FOIL method here. You know what? Maybe I should have shown that. I'm not sure how much algebra you remember. All right. So x plus 2 times x plus 2 plus, that was a plus, right? Yep, that was a plus. Negative x plus 1, negative x plus 1. And if you know how to do all this, feel free to fast forward. So x squared plus 2x plus 2x, my writing's getting better, plus 4 plus negative x times negative x is negative x quantity squared, but it'll just be positive x squared. Negative x times 1, negative x times 1, and plus 1 equals 9. It's quadratic. Combine like terms. 2x plus 2x minus 1x minus 1x, that's 4x, 3x, 2x. I'm hoping I'm getting this right. And 4 and 1 is 5, equals 9. Subtract, we got to get set equal to 0, so you subtract 9 from both sides. Don't want that in my problem. Plus 2x minus 9 is a minus 4. Now I would divide everything by 2. You could go right to quadratic formula or factoring. I think this will factor. X squared plus x minus 2. I divided everything by 2. Both sides divided by 2. 0 divided by 2 is 0. Now, this, I believe, will factor down to x minus 1. Nope, scratch that. Nope, that is right. X plus 2. x squared plus 2x minus 1x minus 2. Okay, so in this, x equals positive 1, and on this one, x equals negative 2. So it would look like my picture's way off, but where it's the x value of one crossing point is 1, and the x value of one crossing point is a negative 2. To find the y value, because this is points of intersection, so you need the y value. Let's see, y equals negative 1 plus 1, which is 0 for this one. So I'm plugging 1 into this. I'm going to plug a negative 2 in, so it's going to be negative 2, which is positive 2, plus 1, which is 3. So your points are, running out of space, 1, 0, and negative 2, 3. Those are your 2 points of intersection. I hope this helped. It was fun for me. Good luck.